Hi, this is Math 6, Lesson 3-7, Simplify Algebraic Expressions. In this lesson, you will combine like terms and algebraic expressions. You will also use properties of operations to simplify algebraic expressions by combining like terms. Okay, let's look at solve and discuss a question. Write an expression equivalent to x plus 5 plus 2x plus 2. Do you see any terms that could be simplified or combined together? Okay, you can look at 5 and 2 together. Can you add 5 and 2? Yes. So you can add 5 and 2 so that it becomes 7. And you have x and 2x. If you have x, if you have a variable with the same power, that means you have a like term. And this is when you can say, oh, I can add the like terms. 2x plus x is equal to 3x. Because 2x really is x plus x. That's 2x. Okay? So x plus 2x is x plus x plus x, which is 3x. Okay? So we have 3x here. All right? So that's really x plus 2x plus 5 plus 2. You reorder them. And then you have 1x plus 2x plus 7, because you add 5 and 2. You have 3x plus 7. And that's as simple as you can get. Okay, you can use the commutative property to reorder the terms. And then use the identity property to call this x out into 1x. Okay. And then you can add the coefficients. So you're using what you know about algebraic expressions and properties of operations to make sense of the problem. Focus on math practices. How do you know that the expression you wrote is equivalent to x plus 5 plus 2x plus 2? How do you know they're equivalent expressions? To justify equivalent expressions, you can substitute any number for x and see if they have the same value for both expressions, right? That's how you can justify equivalent expressions. So you can maybe plug in some numbers for x plus 5 plus 2x plus 2 and plug in some numbers for 3x plus 7. If x is equal to 1, you have 3 times 1 plus 7, which is 3 plus 7, 10. And then 1 plus 5 times 2 times 1 plus 2, which is 6. And then 3, 9, 1 plus 5 is 6. And then plus 2, because 2 times 1 is 2, that's 8. And then plus 2 is 10, right? If x is equal to 2, 3 times 2 plus 7 is 6 plus 7, which is 13. 2 plus 5 plus 2 times 2 plus 2 is 7 plus 4 plus 2, 6, which is 13. Okay, so we do have same values for the same number of substitution. Okay, you can try other numbers too, and they should have the same values, and you can say they're equivalent. So let's write that explanation down. You can substitute any number for x in both expressions. If both expressions have the same value, they are equivalent. Okay. So Think about how you can simplify algebraic expressions throughout the lesson. Example 1. Combining like terms to simplify algebraic expressions. Terms that have the same variable part, such as y and 2y, are like terms. To simplify algebraic expressions, use properties of operations to write equivalent expressions that have no like terms and no parentheses. Okay, you can write simplified equivalent expressions for x plus x plus x and 2y minus y using these properties of operations. Look at the identity property. Identity property of addition is basically a plus 0 is equal to a, and 0 plus a is also equal to a. Okay, identity means you do not change the number. It comes back to itself. Identity property of multiplication is that if you multiply 1, it's the same number as you started with. Okay, distributive property across addition, a times b plus 6, b plus c is equal to ab plus ac. We looked at this in the last lesson. Distributive property across subtraction is the same way, but with subtraction. Okay, so combining the like terms in x plus x, all these three terms, x and x and x, they are all the same variable, right? They're same variable part. They have the same variable and the same power. So you can add them together. X is 1x. Okay, that's the identity property of multiplication. So 1 plus 1 plus 1 times x should be true using distributive property. So you can add the x's together and you have 3x. So x plus x is equal to 3x. 2y minus y, you can combine them together as well. They're like terms. They have the same variable with the same power. Okay, 2y minus y is equal to 2y minus 1y. And 2 minus 1 is 1. So it's 1y or y. Okay, so 2y minus y is just y. Let's try this problem. Simplify the expression for 4z minus z plus z minus 2z. Okay, start with 4z minus z plus z minus 2z. We have 4z minus 1z. And we're going to use the identity property of multiplication to write z as 1z and 2z is just 2z, okay? And then we're going to use the distributive property to group the numbers, the coefficients all together and multiply that out with z because that is our common factor, right? Throughout the whole 4 terms. And then we get how many z's? 4 minus 1 plus 1 minus 2 is just 2z. The simplified expression is 2z. Convince me, how do you know that the expression 2x plus 4y is not equivalent to 6xy? Okay, how is this not 6xy? Are they equivalent expressions? If you substitute and justify, you will not get the same values. So they are not equivalent expressions. But why? Why can you not add the 2 and 4? Because they're not like terms, right? X and Y are not the same term. You cannot add X's and Y's together. They're not like terms. Okay? They do not have the same variable. Only like terms can be combined using the distributive property. You do not have common factor to factor it out using the distributive property, right? So 2x plus 4y is just 2x plus 4y. You can't do anything about it. All right, so let's write that down. The terms 2x and 4y are not, what's the vocabulary? Like terms. Because they do not have the same variable. Okay, only like terms can be combined using the distributive property. Can 2x plus 4y be simplified? No. So 2x plus 4y cannot be simplified. Okay? Example 2. Simplify algebraic expressions with fractions. A new hiking trail includes 3 sections of an old trail. There's a flat section, a hilly section, and a winding section. The park ranger marked the sections of the trail in relation to the length of the flat stretch of the trail, which is n kilometers. What is the simplified expression that describes the length of the new trail? Okay, so we got 2/3n plus 4, and we got n here, and 2n. So all together, the whole trail should be all of these expressions added together, right? So that's 2/3n plus 4 plus n plus 2n, right? So you're going to write an expression that represents the total length of the trail and then simplify. Simplify this expression. You can group the like terms. We got n and 2n plus 2/3n as like terms. And now you can use distributive property to factor out all the n's out, okay? And all the coefficients could be added together. 1 plus 2 plus 2/3 are going to be 3 and 2/3n. And don't forget your 4 plus 4. So that's it. There are no more like terms. And now 3 and 2/3 n plus 4 should be the equivalent expression for n plus 2n plus 2/3n plus 4. Okay, let's try this try question. Park rangers add another section to the trail represented by the extension 1/2n plus n plus 1/2. So we have more length added to this expression, this trail. Okay, maybe here, over here. So that could be represented as 1/2n plus n plus 1/2. Write an expression for the new total length. So figure out the total length of the trail, then write a simplified equivalent expressions. We gotta add all the length down. So we have n plus 2n plus 2/3n, okay, plus 4 plus 1/2n plus n plus 1/2, right? And looking at the like terms, put all the n's together. We got n plus 2n plus 2/3n using the commutative property. Move 1/2n and n over here, and move all the constants at the end. 4 and 1/2, right? So then you can factor out n using distributive property and say, oh, that's 1 plus 2 plus 2/3 plus 1/2 plus 1 plus 4 plus 1/2. And what are all these combined? 1 plus 1 is 2, 2 plus 2 is 4, 4 plus half is 4.5, 4.5 plus 2/3. How do you add that? 4/2 plus 2/3 and 4/2 over here, right? So then you have to change your fractions. That's going to be really 4 and 3/6 plus 4/6, right? And then, so you have, wait, this is your first expression. When you simplify, you get, that's really 7 over 6. But 7 over 6 is 1 and 1/6, right? So you have 4 plus 1, that's 5, and 1 over 6, n, plus 4 and half as a simplified equivalent expression. Okay? Let's look at example 3. Simplify algebraic expressions with parentheses and decimals. This summer, Vanna wants to charge 2.5 times as much for mowing and raking, but her expenses, which is $10 per weekend, will also increase 2.5 times. The expression below can be used to find how much Vanna will make the summer mowing and raking X lawns in a weekend. Okay, so we got this expression, 2.5 times, parentheses, 20.50x plus 5.50x minus 10. How can you use properties of operations to write a simplified equivalent expression without parentheses? You want to get rid of the parentheses. This is where you use the distributive property and distribute them out. Okay, distribute 2.5 out into all these terms. Right? And then, or before you do that, you can also simplify these two. You can combine like terms and get, oh, that's 26, and 26 is easier to calculate than 20.5 and 5.5 separately, right? So you can first combine your like terms, and then you can distribute 2.5 out and multiply them into these two terms. You have 2.5 times 26x minus 2.5 times 10. And if you multiply them out and simplify, you get 65x minus 25. So 65x minus 25 should be equivalent to 2.5 times 20.5x plus 5.5x minus 10. So when you simplify expressions, that can make the expressions easier to evaluate for a lot of problems. So you need to know how to simplify expressions. Let's try this question. Suppose Vanna increases her rate by 3.5 times and her expenses also increase by 3.5 times this summer. Write two equivalent expressions to represent how much she can earn mowing and raking grass. So together you can say, oh, 20.5x, everything that goes into parentheses are going to be the same, right? That's how much total she'll make. And her expense would be 10 per weekend. So this is how much she earns, and she uses 10 times 3.5 times, right? So then you have the same terms in your parentheses. 20.5 x plus 5.5x minus 10. That's total earning and expense of her weekend. But she will increase her rate by 3.5 times. Okay, both rate of her expenses and the increase, right, of her income. So then you're going to use the distributive property to simplify this expression to get an equivalent expression. Okay, so first we can say 3.5 times 26x minus 10 would be the same because you add the like terms. And then you multiply 3.5 times 26x and 3.5 times 10. And then you have 91x minus 35. Okay. So in this lesson, you learned how to combine like terms to write equivalent expressions. Like terms have the same variable part. So keep in mind that the same variables with the same power are like terms. So first you need to identify like terms, then you can use commutative property to order them differently and add them. Add the like terms and combine them to simplify expressions. All right, that was 3-7, simplifying algebraic expressions. And this was the last lesson of this topic. Bye. Great job, guys.